In our today's video, we are going to discuss about what is subnetting, how to do subnetting, how to find the number of hosts and the network ID from a CIDR value, how to find a subnet mask from any IP address. Hello friends, this is Abhishek here and welcome back to my channel Technical Tech. Let's the tech begin. So guys, what is subnetting? Dividing a large network into multiple small networks, we called it as subnetting. Before starting the concept subnetting, I would like to explain you about few basic things. Because if you don't know the basic, it will be very difficult for you to understand this subnetting concept. So guys, please watch this video till the end, then only your all the confusion and doubt will be clear. Let's start with the classes of IP address. As we know that class A IP address starts from 1 to 126. Its default subnet mask is 255.0.0.0 and its default CIDR value is 8. Now, what does this CIDR value means and why the default CIDR value of class A IP address is 8? CIDR stands for classless inter-domain routing. It is the total number of network bits. As here you can see, in class A IP address, there are 8 bits reserved for the network and the remaining bits are reserved for the host. So these 8 network bits is a CIDR value. That's why the default CIDR value of class A IP address is 8. Now let's move on to class B. Class B IP address starts from 128 to 191. Its default subnet mask is 255.255.0.0 and the default CIDR value is 16. As we know that the total number of network bits in class B IP address is 16. So its CIDR value is 16. Now let's move on to class C. Class C IP address starts from 192 to 223. Its default subnet mask is 255.255.255.0 and the default CIDR value is 24. Now why we have written the CIDR value as 24? Because total number of network bits in class C IP address is 24. That is why the CIDR value of class C IP address is 24. Now let's take an example so that I can clear the concept for you. As here you can see, it's mentioned here 192.168.10.0 with the CIDR value 24. As we know that it is a class C IP address because the IP address starts from 192 and its default subnet mask is 255.255.255.0. Now the question is, where does this subnet mask come from? Why the subnet mask of class C IP address is 255.255.255.0? As we know that IP version 4 is a 32-bit address and it is divided into 4 blocks of 8 bits where number 1 indicates the network bits and 0 indicates the host bits. Bits on each blocks are counted from right to left and it is written as 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, 5, 6 and 2 to the power 7. So if you add all these network bits, the total number you will get is 255. So the default subnet mask of class C IP address is 255.255.255.0. Now why we have written here 0? Because it is a host bit. You can calculate the subnet mask only from the network bit, not from the host bit. That's why we have written here as 0. Hope the concept is clear for you. Let's take another example. The IP address 192.168.10.0 with the CIDR value 25. Hence the IP address is same as our previous example, but this time we have changed the CIDR value from 24 to 25. As we know that the default subnet mask of class C IP address is 255.255.255.0 because by default there are 24 bits reserved for the network and 8 bits reserved for the host. But in this scenario the CIDR value is 25, which means there must be 25 network bits. Okay, now the question is, in class C IP address we are having only 24 network bits. Now from where to find another 1 bit? The solution is very simple. We have to borrow 1 bit from the host. So the new subnet mask which you will get is 255.255.255.128. Now from where do we have found this 128? This number came from the network bit which we have borrowed from the host. As here you can see guys, the value of that particular network bit is 2 to the power 7. Hence once you calculate 2 to the power 7, the total number you will get is 128. So for that reason the new subnet mask of this address is 255.255.255.128. Is it clear guys? If not, nothing to worry, I will also show you another example. But first of all, let's look at how to find the number of network from this address. Just follow this small formula, 2 to the power n. Here n indicates the total number of bits you have borrowed from the host. Hence we have borrowed only 1 bit, right? So the total number of network you can create is 2 to the power 1. Which is equal to 2, means only 2 network can be created. Now let's find out how to find the number of IP address on each network. The formula is very simple. Again we have to use 2 to the power n, but this time n indicates the total number of host bits. Hence we have already borrowed 1 bit from the host. So how many total bits remaining in the host part? It is 7. So we are going to use 2 to the power 7, which is equal to 128. Means on each network you will get 128 IP address. Now let's find out how to find the number of hosts on each network. Guys, these two topics are really different. Number of host and the number of IP address. Number of IP address means total number of IP address you will get on each network, and number of host means total number of IP address you can assign to the devices in a network. So I will explain you that. Hence the formula is 2 to the power n minus 2. Here n indicates the total number of remaining host bits, which is 2 to the power 7 minus 2, which is equal to 126. It means you will have total 126 host IP address on each network. Means you can assign 126 IP address to the devices in a single network. Now the question is, why we have subtract 2 here? Because on every network the first IP address is reserved for the network ID and the last IP address is a broadcast ID, and these two IP address you cannot use. For this reason on every network we have to subtract 2. So as here you can see guys, in network 1 the IP address will start from 192.168.10.0 and it will end at 192.168.10.127, which is equal to 128. Now as I have explained you, the first IP address is a network ID and the last IP address is broadcast ID. Means these two IP addresses you cannot use as it is reserved for the network and the broadcast. The IP address which is available at the center of this IP address, that is from 192.168.10.1 to 192.168.10.126 are the host IP address, and this IP address you can assign to devices in a network. Same like this, in network 2, the IP address start from 192.168.10.128 and it will end at 192.168.10.255. Hence, I have explained you earlier, the first IP address is a network ID and the last IP address is a broadcast ID, and the IP address which you are getting at the middle of this are the host IP address, and this IP address start from 192.168.10.129 to 192.168.10.254. These are the IP address which you can assign to the devices in a network. So guys, hope the concept is clear. Let's take in another example. As here you can see the IP address 192.168.10.0 with the CIDR value 26. The IP address is same as our previous example, but this time we are using a CIDR value 26. As we know that it is a class C IP address because the IP address start from 192, and by default the class C IP address subnet mask is 255.255.255.0. Now why the subnet mask of class C IP address is 255.255.255.0? Because in class C IP address 24 bits are reserved for the network and the 8 bits are reserved for the host. So if you count the value of all these bits on each block, you will get the total number of 255.255.255.0. But the question is, the CIDR value is 26 and the default network bits on class C IP address is 24. So from where do we get another 2 bits? Yes, we have to borrow it from the host. So once you borrow the 2 bits from the host, the new subnet mask what you will get is 255.255.255.192. Now how do we get this number 192? Because we have borrowed 2 bits from the host, and if you calculate the bits value, which is 2 to the power 7 plus 2 to the power 6, the total number you will get is 192. So this is how you can find the subnet mask. Now let's move on how to find the number of networks. The formula is very simple, 2 to the power n. Here n indicates the total number of bits borrowed from the host. Hence we have borrowed 2 bits from the host, so we are going to write 2 to the power 2, which is equal to 4. It means you can create total number of 4 networks. Now the question is how to find the number of IP address on each network. The formula is 2 to the power n, but in this scenario n indicates the total number of remaining hosts. As we have taken 2 bits to the network, so how many bits remains? It remains only 6 bits. So we are going to write 2 to the power 6, which is equal to 64. It means you will have 64 IP address on each network. Now let's look at how to find the number of hosts on each network. Guys, number of IP address and number of hosts are both different. Number of IP address means total number of IP address you will get on each network, and number of host means total number of IP address you can assign to the devices in a network. So the formula is 2 to the power n minus 2. Here n indicates the total number of remaining bits. Okay, so how many total bits remaining? We have remained 6 bits, so we are going to write 2 to the power 6 minus 2, which is equal to 62. It means you can assign 62 host IP address on each network. Now the question is, why do we have subtract 2 here, right? We have subtract 2 here because on every network the first IP address is reserved for the network ID and the last IP address is reserved for the broadcast ID, and these two IP address you cannot use. Hope the concept is clear. As here you can see the net. So the total number of network we have 4. Total number of IP address on each network is 64 and the total number of hosts on each network is 62. So hence we have 4 networks. So let's name this network as network 1, network 2, 3 and 4. Now how to find the network ID for this? We have to just keep adding 64, 64, 64, 64. So like that you can easily find the network ID. So the network ID of first network will be 192.168.10.0 and the network ID of second network will be 0 plus 64. How much it is? 64. So it will be 192.168.10.64. Now the third network ID will be 64 plus 64, 128. So it is 192.168.10.128. Now what will be the fourth network ID? It will be 128 plus 64, which is equal to 192. So the network ID of fourth network is 192.168.10.192. So this is how you can find the network ID. Just you have to add the total number of IP address on each network and you will find the network ID easily. Now let's find the total number of hosts and the broadcast address. Hence our IP address start from 192.168.10.0. So its host definitely start from 192.168.10.1 to 192.168.10.62. And the last IP address, which is broadcast address, is 192.168.10.63. Same in network 2, the first IP address is 192.168.10.64, which is also called network ID, and its host start from 192.168.10.65 and it will end at 192.168.10.126 and its broadcast address will be 192.168.10.127. What is broadcast address, guys? The broadcast address is the last IP address of each network. Same you can see the third and the fourth network. So guys, hope the concept is clear for you. If you are having any doubt or want me to make another video on subnetting, please let me know in the comment section below. With that, you can also download our Android application Networking Plus from the Google Play Store, and also you can download it from the link given in the description section below. Now it's time for the test. So here I'm going to ask a small question. It is 192.168.10.0 with the CADR value 28. Now tell me guys, what will be the subnet mask for this? Find the total number of network can be created from this. Find the total number of IP address on each network. At last, find the total number of hosts can be assigned on each network. Answer this question in the comments section below and let's see whether you are able to pass this test or not. I will tell you the answer in my next video, so please subscribe to my channel. Thanks for watching.